Hello friends, welcome to the course of numerical methods and optimization. Unit number 1, roots of equation and errors approximation. In this session, we will try to understand the second method, Newton Raphson method. In earlier lecture, we have already covered what are the algebraic and transcendental equation and one numerical method known as bisection method for the solution of algebraic and transcendental equation. Newton Raphson method is also used to determine the roots of algebraic and transcendental equation. Now, basically, the Newton-Raphson method, it is an open-end method, while the bisection method was a, or bisection method is a bracket method, which required two initial approximations, while Newton-Raphson method requires only one initial approximation. Now let us consider we are having x0 is the initial approximation or the initial approximate root to the function f of x is equal to 0. Now, by using that, we will go to the second approximation, that is x1. Now, x1 is equal to x0 plus h. If, now let's suppose, is x1 is a root of equation, then we can say that f of x1 is equal to 0, so it satisfies our conditions. Now let expand the f of x0 plus h by Taylor series. We get f of x0 plus h into f dash of x0, f of x0 plus s square by 2 factorial into f double dash f of x0 plus terms with a higher power of h square and higher derivative of f is equal to the 0. Since h value is very small, so we can neglect the terms of higher values of h square or the higher power of h. Finally, we get f of x0 plus h into f dash of x0 is equal to the 0. Now rearrange the term, we get a final value of h as f of x0 divided by f dash of x0. Let it be equation number 1. Now substitute this value of h in equation x1 is equal to x0 plus h. We get a next approximation to the root x1 from the initial approximation x0, that is x1 is equal to x0 minus f of x0 divided by f dash of x0. Now let's go to the second approximation. The next approximation to the root x2 is given by x1 minus f of x1 divided by f dash of x1. Consecutively, we will go to the further approximation till the desired level of accuracy is achieved. So in general, we can say that xn plus 1 is equal to xn minus f of xn divided by f dash of xn, which is known as the Newton-Raphson formula or Newton iteration formula. The important thing that what differentiate or what we can say the requirement of Newton-Raphson method, that is we require one initial approximation x0, or we can say we require initial approximation xn. From that we get a next approximation to the root is xn plus 1. An important thing that you should be able to determine the derivative of function f of x. The proper determination of derivative is also important to determine the root of equation using Newton-Raphson method. Graphically, it is also represented as here. Let y is equal to f of x is represented onto x and y plane. Now what we are having initial approximation is x0. Now we will draw tangent to the function at x0. It will intercept to the axis at x. That gives the next approximation x1. Now again at x1 and y1, we will draw tangent to the function which will intercept to the x-axis at x2. And again from point x2 and y2, we will draw tangent to the curve which will intercept to the x-axis till we move further toward our root of equation, that is alpha, where the function value y becomes 0. So that is the root of equation here. Alpha is the root of equation. Now, Newton-Raphson method generally used to improve the results obtained by other methods. So what we can say, we have to determine the initial approximate root, and further we will try to go on improving this root value with the help of Newton-Raphson method. It is applicable to the solution of both algebraic and transcendental equations. So this is all some basic things about the Newton-Raphson method. Let us understand the method with a simple example. Find the root of equation x4 minus x is equal to 10 correct to 3 decimal place with the initial case of 2 using the Newton-Raphson method. What is given? The function f of x is x4 minus x minus 10. Initial case x0 is 2, and after derivating this function, f dash of x is equal to 4x cubed minus 1. What is Newton-Raphson formula? Xn plus 1 is equal to xn minus f of xn divided by f dash of xn. Now let us first iteration put n is equal to 0. What we get? X1 is equal to x0 minus f of x0 divided by f dash of x0. So substituting corresponding values of x0, f of x0, f dash of x0, that is x1 is equal to x0 minus f of 2 divided by f dash of 2, we get a 2 minus substituting f of 2 is 4, substituting f dash of 2 is 31, we get a x1 is equal to 1.871. Goes to the next iteration, putting n is equal to 1, we get a second approximation as x2 is equal to x1 minus f of x1 divided by f dash of x1. Substituting the corresponding values of f of x1 and f dash of x1, that is 1.87 minus f of 1.87 minus divided by f dash of 1.87. Substituting the corresponding values, we get a x2 is equal to 1.856. Now proceed to the next iteration, third iteration. Put n is equal to 2, we get x3 is equal to x3 is equal to x2 minus f of x2 divided by f of x2. Now x3 is equal to 1 point, substituting corresponding value of x2 and f of x2 and f dash of x2, we get a value of x3 is equal to 1.856. Now what has been said in the problem, to correct determine the root up to correct the decimal 3 decimal places. You can check in the second iteration the root value is 1.856. Again in the third iteration the root value is again 1.856. So we can stop our calculation and the root of equation is 1.856, which is correct up to the 3 decimal places. Very simple method. An important thing or the critical thing is that you should be able to determine the derivative of function when the equation may contain certain algebraic, logarithmic, trigonometric, or exponential function. After that, you can carry out the simple calculation using formula xn plus 1 is equal to xn minus f of xn divided by f dash of xn. So this is all about Newton Raphson method. Thank you.